Precalculus first mid 6 weeks common assessment 2016-2017 school year. This test is over the topics of mainly domain, discontinuities, increasing, decreasing, relative maximums, minimums, horizontal asymptotes. I'll just assume. Okay. So let's go over the problems themselves. What is the domain of the function f of x equals x over x minus 3? And for this, we can look for exclusions. As we find exclusions to the domain, we will know what the domain is. Since we cannot divide by 0 in math or in algebra, we know that this denominator of the function, x minus 3, cannot equal 0. And so if we add 3 to both sides of this inequality, we get x cannot equal 3. So any part of this, any piece here that has 3 in it, all real numbers has 3 in it, no good. 3 exists here in this right interval. This one on the D is all real numbers also. It just has to be up to and including, up to and not including 3 and greater than 3. It's got to be this one. Should you have any doubts about it, you can go to a graphing calculator, and if we go to add graph, I can go find, I pre-entered a lot of these functions from this test. There it is. We press that, we see a discontinuity at x equals 3, a vertical asymptote, non-removable discontinuity. If we press Control T, we will see also undefined here at x equals 3. So a lot of different ways to solve this one. 2, for the function g of x equals x squared over x times 20x minus 1 times 20x plus 3. What are the exclusions to the domain? Again, exclusions, what the domain cannot be. Okay, what domain cannot be. And what I did for this one is I didn't preload this particular equation. Let's I'll give my reason for it in a minute. If I press Control I, enter a new function. Okay, Control, and we have x squared over x times quantity x minus 1 times quantity x plus 3. Press that. Oh, cannot accept change, invalid input. Well, I did this on purpose. Your TI Inspire calculator, it's a great calculator, but sometimes it'll recognize variables as text. And so what I'm going to do here is enter, I'll just go to Control I, get another page, add graph. This time, watch what I do differently. I put x squared as before, but in the denominator, we're going to put x times. It's that times that's important. And we're going to have x quantity x minus 1 and times quantity x plus 3. And we press that, and we get our some discontinuities. See a discontinuity at x equals -3 and at x equals 1, vertical asymptotes. So anything that does not have those two discontinuities, we will just eliminate. Okay. 1 and negative 3. And 1 and negative 3. So that could be, okay, that's negative 1. 1 and negative 3, it has 3 and negative 1. Okay. So those two are eliminated. So now it's between choices A and C. Well, it's kind of a trick question. If you're really not careful about it, you'll pick A. You can find the discontinuities or the exclusions by setting each one of these factors. We have x times quantity x minus 1 times quantity x plus 3. And we set each one of these equals 0, so x cannot equal 0. X minus 1 cannot equal 0. And finally here on the right, x plus 3 cannot equal 0. And so x cannot equal 0, that's an exclusion. So C is going to be our correct answer. X adding 1, x cannot equal 1. Subtracting 3, x cannot equal negative 3. That's our answer. If you just looked at the graph itself, you would have seen these two vertical asymptotes right here at x equals negative 3 and x equals 1, and you would have been tempted to pick answer choice A. Be careful about that. 3. Which of the following graphs is not that of a function? Well, there's something we can use called the vertical line test. If we go get a line here, we can create a vertical line, and this vertical line that we've created we can move to this graph. There we go. There we go. See, touches more than once. So our answer is A. It fails the vertical line test. Next problem. 4. Which type of discontinuity will not likely be seen when examining the graph view in a graphing calculator? Well, that would be a point discontinuity, which would be a removable discontinuity, or a hole. That is the only correct answer. Each one of these, A, B, and C, can be easily seen on a graphing calculator, but D not. Again, point discontinuity or removable discontinuity would be a synonym for a hole. 5. What is the domain of the function f of x equals 2 times quantity f minus x? Well, for this, if we go inside a radical, we know that what's inside the radical has to be greater than or equal to 0. It cannot be negative. You can't have negative. So if we subtract 4, keeping the unknown on the left side, we have negative x is greater than or equal to negative 4. And if we divide both sides of this inequality by negative 1, we get x, and we have to switch the direction of inequality, and x is less than or equal to 4. And this equal to is the bracket. It's not negative 4, it's positive 4. So our correct answer for this one will be answer choice B. And looking at our graphic calculator, graph, we're going to look at the graph of this, and there it is. Press enter, we see the graph going to the left of 4. If we go to table view, Control T, we will see that at 4 the function is defined, but after 4 not defined. So our properly written domain in interval notation is answer choice B. 6. Which function is increasing for all real numbers? You can graph all these. Now I want to go ahead and graph answer choice A, the cube root. F of x equals the cube root of x. So let's go to calculator. Okay, where to do that is you press Control and this exponent key on the left, and up here you can press 3 and then X. Here, press Enter, and the function is increasing for all real numbers from greater than negative infinity to less than infinity. So our correct answer to this one is going to be answer choice A. Next, 7. The graph of f of x is shown below. Which statement about the graph of f of x is true? We just examine these statements one by one. F of x is decreasing on -2 to 3. So here's -2 to 3. Looks like the function is decreasing. That could be right. We'll check choice B. F of x is increasing on -3 to 1. So here's -3 to 1. Now, things increasing from -3 to -2, but not over that whole interval. F of x is decreasing on 3 to 8. Well, again, looks like things increasing on 3 to 8. Not right. Choice D. F of x is decreasing on 5 to 3. Well, looks like it's decreasing on -2 to 3. Well, 5 to 3, how did that happen? Oh, yeah. That's kind of a trick one, because if you look at 5, if you go 5 here, all the way down to 3 here, so those numbers are in some ways related, so that's a little bit of a trick deal. But A is our correct answer. 8. For the graph of function g of x shown below, where is a relative maximum for the function observed? Well, the only place I see a relative maximum is right here. But now is where the trick comes. Where? Okay, where, the words where or when refer to x values. So where would be at x equals 4. Okay, so x at x equals 4. I think a lot of people pick answer choice A at y equals 5. Well, the value is 5, so really where or when refer to x values. What can be maximums usually, or minimums, or let me just state it otherwise. I'll say what y values or output values. So kind of a tricky one, very, very tricky. Anyway, I hope that gets you ready for next time. Where refers to where the x value does that maximum occur. 9. Which of the following functions is a parent function? This is one that just knowledge is. You're looking for the simplicity of functions. Actually, A is kind of close, but it's the proper parent function would be f of x equals x. This choice is B because it's the reciprocal parent function. 10. A vertical asymptote is what kind of discontinuity? Well, vertical asymptote is an infinite discontinuity or a non-removable discontinuity. So therefore our correct answer will be A. Now, point is related to removable discontinuity. Point discontinuity is related to removable discontinuity or whole. So these others are not correct. A is your correct answer. 11. For the function x cubed plus 1.5x squared minus 6x, over what interval is the function decreasing? So I think I have this one in the calculator someplace. Control I. And I will go down and find it. Where is it? Oh, I think that's it. Yeah. No, that's not it. There we go. This is it. The black one here. Okay, so what I will do is go to graph, trace, and it's what it's doing is it's taking the green one. I want the black one. Okay, here we are at the top maximum at x equals -2. We go to the right to the relative minimum to 1. So from -2 to 1 is where the function value is decreasing. So we go back here and say from -2 to 1, C is our correct answer. Next, which of the following represents the end behavior for the function f of x equals 1 over x? Well, we can graph this function quite easily. The function 1 over x, f of x equals 1 over x, goes like this. And as x gets bigger and bigger, what does y go toward? Well, it goes towards 0. So we say the limit as x approaches infinity of f of x equals 0. Next, 13, for the function of f of x equals x cubed plus 1.5x squared minus 6x minus 2, what is the relative minimum of the function? And for that, I'm going to go to Control I again, add graph, and we're going to get that same function we had earlier, except we're going to do one more thing, subtract 2. And so the relative minimum is going to be down here. And to find that, if we can go to graph trace again. We could also go to analyze graph. We press analyze graph and get a minimum. It says lower bound. We set that lower bound. We go to the right. Our minimum is at -5.5. Well, it's at the minimum is -5.5, which occurs where x equals 1. So we look for the -5.5, and that's what we have. So that is our answer to 13. 14, which of the following functions is bounded? Well, the correct answer for this is going to be answer choice A. That's going to be the sine x function that looks like this. It oscillates between y equals 1 and y equals -1 and keeps on going. And so we say there's a lower boundary below which the function does not go, and likewise an upper boundary above which the function does not go. So we say the function is bounded. A is our correct answer choice. Next, 15, the function f of x equals x squared over x times quantity x minus 2 times quantity x minus 1 contains how many discontinuities? Now, if you take x cannot equal 0, right? That's 1. X minus 2 cannot equal 0, so x cannot equal 2. And finally, x plus 1 cannot equal 0, so x cannot equal -1. So how many do we count there? 1, 2, and 3 discontinuities. Okay, right there, the answer is 3. Doubting, go to your calculator, Control I, add graph, and I'm going to go enter this function. We see 2 vertical asymptotes, but if we go to table view, like we should, we see undefined at x equals 1, scrolling up, undefined at x equals 0, and undefined at x equals -3. 3 discontinuities. I think people who got this wrong probably put 2 because they just might have looked at the vertical asymptotes and noticed 2 of them. So if we put 3, we can fill in the plus or not, and just come down here and fill in the 3 bubble, and we would have our correct answer. Next, 16. The elevation in feet of ball thrown in the air is given by a function ft equals 6 plus 8t minus 16t squared, where t is the number of seconds and nearest foot. What is the maximum elevation of ball? Mark your answer in the group provided. Oh, I saw a lot of people get this one wrong. People weren't not thinking. What were they thinking? Let's go ahead and take a look. If we go to our calculator, Control I have preloaded this function here, which is this one. And if we graph the function, that's what it looks like. And so if we go find the maximum, we can use graph trace. There are other ways we can do it, but graph trace 1, and we just go to the right till we get a maximum. Just keep on going. And at the very top, it says maximum. Okay? Can you see that? Maximum 2 point, it's got maximum up there. See that? I'll go there again. There it is. See, it says maximum. 2.75, comma 127. Oh, I saw a lot of answers for 2.75 for this. That was highly frustrating because those answers were not even possible. If you throw a ball up in the air, is it a reasonable answer that that ball's highest elevation is going to be 2.75 feet? No, it is not. Okay, now the thing asks, now how many seconds does it take for that ball to reach its maximum elevation? Then 2.75 would be the correct answer. So I'm going to fill in 127, like everybody should have. So 1, 2, 7. There we go. Now number 17. For the rational function fx equals 5x squared minus 6x plus 7 over 2x squared plus 10x. I spent a lot of time talking about Betsy, Bobo, and Botu. Betsy, it stands for bottom equals top. Use coefficients. And specifically, when it says bottom equals top, what that means is the power. Okay, the power of 2 is the highest power on the numerator, and the power of 2 is the highest power in the denominator. So then our horizontal asymptote is going to be y equals the coefficients. Use coefficients, which is 5 over 2, which simplifies to 2.5. And in your calculator, that's one of the ones I preloaded. Control I, add graph, and I go here, and there it is. You press enter, we see these different pieces. If we can use a real high number because we're looking for the definition of a horizontal asymptote is the limit as x approaches infinity or negative infinity. So let's go ahead and approach infinity by going menu, trace 1. And we're just going to trace to the right here and look at the y values. Okay, the y values are now, okay, we're going to the right here, 1 point, going up. Now it's going to 2, and we'll keep on going up. What is going to be approached? Well, we can stand here for minutes and get pretty close to 2.5. But there's another way to do this. I showed people in my class, and you see the thing getting closer, so it's going to get closer to 2.5. So you see we're up to 200 x value. But if we go to Control I and add calculator, use a real huge number and store it. I used 1 trillion. 1 with 12 zeros after it. 4, 5, 6, 7, 8, 9, 10, 11, 12. And I press Control bar X. Okay, so we've stored 1 trillion to that. And next, all we have to do is enter the function, and we're going to get really close to the answer. And so we're going to put 5x squared. Let me get a 5x squared minus 6x plus 7. And in the denominator, we have 2x squared plus 10x. And we get this fraction here. If we press Control Enter, we get the decimal approximation, which is 2.5. There it is, 2.5. So put 2.5, and that's going to go like this. Here's your 2, there's our 2, here's our point, and here's our 5 right down here. And there it is, bubbled in correctly, number 17. Well, good luck, and I hope this helps, and I thank you for viewing.